wondered the data scientists and AI engineers generate random numbers for simulations, cryptography, and machine learning models? Or how can they handle massive data sets with just a few lines of code? Well, the secret lies in Python library called NumPy. It's the backbone of numerical computing in Python, and in this tutorial, we will explore some of the most powerful NumPy methods. In the previous video, we explored NumPy attributes like ndim, dtype, and shape, creating a 1D and 2D arrays with a practical approach to learning NumPy. If you haven't watched it yet, be sure to check it out before moving forward. If you are serious about working with data, understanding NumPy is a must. In this session, we are diving into the most important inputs like NumPy methods and generating the random numbers, both essential for the data science, machine learning, and numerical computing. We will cover some fundamentals NumPy methods that helps in array manipulation and reshaping. We will look at the reshape to change any dimension and modify arrays using resize and also transpose to swap rows and columns. We will also explore ones and zeros which allow us to create new arrays filled with ones and zeros, and use it also identify which generate matrices to mathematical representations. These methods are essential when working with the large data sets and performing the mathematical computations effectively. In these methods, we will move to generating the random numbers, a key concept in simulations, AI, and statistical modeling. NumPy's random model powers several functions to generate the different types of random values. We will explore random sample for generating the random float numbers, random int for generating the random integers, allow us to generate the random data sets, shuffle data, and simulate the real world scenarios to the computational models. I have created a Jupyter notebook where we can discuss the methods in NumPy. Firstly, to discuss about the methods, we need to import the NumPy module. Importing NumPy as import NumPy as np, and I am calling the function. Here I have imported the NumPy. And firstly, as we discussed that resize is a method which is used to resize all the elements and the shape doesn't change. Here the syntax is np, we are calling np from np dot resizing. A is the previous array and the new shape should be created. For example, as you can see, I am creating an array of a equal to np dot array where the elements are the second array. I wanted to create a two-dimensional array. The second array here comes. As you can check, the shape is 2, 4, and just clicking by A, we get the array matrix. In resize, the elements can be increased or decreased, but in reshape, the number of elements should be same as an input and an output. We just here changes the shape of the array. The next one comes transpose. The transpose is similar to the matrix transpose where the rows are changes to columns and the columns changes to the rows. Here by using the transpose, the rows has turned into columns and the columns changes into rows. And then another method called zeros where an array of full of zeros are being created. It is created quite easily by using just np dot zeros. And what is the shape you want to declare? I want a shape of 3, 4. So I was declaring it and I was just calling it. As you can see, the default value of this is floating value. If you want to change or convert the floating value into integer, you just set the d type as integer value. It is quite similar to the ones. In zeros place, I was creating ones and you will be getting the ones value. Here I have created the values of ones. And we also have an identity method which is similar to the identity matrix where the principal diagonal elements will be resemble as 1 and the remaining numbers will be zeros. To create that, it is quite similar identity of shape of 5. I was just calling. So here the principal diagonal elements will be 1 and the remaining is zeros. It's quite simple. These are the mostly commonly used methods in NumPy. Here the next topic comes generating a random numbers. In NumPy we do have many packages and random is one of them. Here in machine learning, if you want to train a data or a model, we use random numbers. We can't use a real-time data, so we use the random numbers. For creation the random numbers, we do have some of the functions. In NumPy, we have many packages and the random is one of the package. For generating the random numbers, we use some of the functions of random. The first one is random sample. Random sample is a function which is used to get the values in between 0 and 1. For example, a equal to np dot random is a package which we need to declare here and random sample, random underscore sample. Here the syntax is we just need to declare this size. I was declaring the size of 8 and just calling the function. Here I got some random numbers in between 0 and 1. Here we get random numbers in between 0 and 1. When you call it again, the numbers will be changed. As you observed, it was 0.8195 and again after your calling, it was changed. The total numbers will be changed. The second one is rand int. Here it will be producing the integer values where a equal to, let us take an example, a equal to np dot random is a package dot rand int. And here we need to give the numbers in between. Like here I wanted to declare the numbers in between 30, 50 with a size of 5, 5. And I was calling the function. Here as you can observe that the numbers were some random numbers in between 30 and 50. And after you call it, the numbers will be changed. These are the two random generating numbers which were mostly used. And for example, you can check in as you can check here the random numbers is used in machine learning. It is needed for the stochastic optimization and also you can check that how can we use the random numbers in machine learning? It is used to train the more robust and accurate models. Here are some questions, just have a look. The first one is generating the 20 random numbers in between 50 and 150. Here the 50 and 150 are the integers, so we by using the randint just generate the random numbers. And the second one is create a 3 cross 3 matrix using the zeros and ones methods. You can use by zeros and ones method, you can easily solve this. The next one is create a 4 cross 4 matrix by using a range, generating a sequence of numbers method and also reshape it using the reshape method. The next one, the final one is creating an array of 50 random integers, random floating numbers between zeros and ones. In between zeros and ones by using the random sample method. Go through the questions and comment your answer below. To recheck your answers, check out the description. Thank you. Keep learning and grow with us.